Does GIT prevent data degradation? I read that ZFS and btrfs use checksums to prevent data degradation, and I read that GIT has integrity through hashing essentially everything with each commit. I was going to use a GIT server on a Linux NAS with btrfs RAID 1 for storage, but if GIT has integrity, I guess this wouldn't be necessary, at least not if preventing data degradation is all I want. Question. So does GIT's integrity, though hashing essentially everything with each commit, prevent or help against bit rot?
GIT's hashing only happens at the time commits are created, and from there on the hashes are used to identify the commits. This in no way ensures the integrity of the files. GIT repos can get corrupted and lose data. In fact, GIT has a built-in command to detect this kind of loss, btrfs, but as the documentation says, you are responsible for restoring any corrupted data from backups.
Depends on what you mean by prevent. First of all, bit rot is a term with multiple definitions. This question is not about code becoming unrunnable due to lack of maintenance. If you mean by prevent that it will likely detect corruption by decay of bits, yes, that will work. It will however not help to fix that corruption. The hashes only provide error detection, not correction. This is generally what is meant by integrity, the possibility to detect unauthorized/unintended manipulation of data, not the possibility to prevent or correct it. You would generally still want a RAID 1 together with backups, possibly implemented with ZFS snapshots or similar. I am not familiar with the ZFS semantics on RAID 1 plus snapshots, for several reasons. If a disk fails fatally, you either need a RAID 1 or a recent backup to restore your data. No error correction can correct for a whole disk failing, unless it has a full copy of the data, RAID 1. For a short downtime, you essentially must have RAID 1. If you accidentally delete parts or whole of the repository, you need a backup. RAID 1 doesn't protect you since it immediately reflects the change to all devices. Block level RAID 1, e.g. via LVM or similar, with only 2 disks in itself will not protect you against silent decay of data, though. The RAID controller cannot know which of the 2 disks holds the correct data. You need additional information for that, like a checksum over files. This is where the ZSF and btrfs checksums come in. They can be used, which is not to say that they are used in these cases. I don't know how ZFS or btrfs handle things there to distinguish which of the 2 disks holds the correct data.
Prevent bit rot? No, it does not, in no way at all. There is no RAID-like redundancy introduced by Git. If the files in your .git directory suffer bit rot, you will lose stuff just as usual. Help against bit rot? Why? No, it does not help against bit rot occurring, but it will help to detect bit rot. But at no point during normal use does it do so by its own account. Well, obviously it does when you check out some objects and so on, but not for your history. You would have to create cron jobs to recalculate the hashes from the content and compare them to the actual hashes. It is pretty trivial to do so. As Git hashes are literally simply the content hashes, it is trivial to recalculate them, and Git fsck does so for you. But when it detects bit rot, there is nothing in particular that it can do against it. Specifically, as larger chunks are automatically compressed, you will likely incur total chunk loss if a bit in a larger object is flipped.
Here,